representation, kind of more compact representation, represent the data in terms of matrix format. So that's what I mentioned the last time here. I just want to review that again because in many cases we might use that. So we're going to represent the entire training data set through the matrix here, something called a data matrix. So what you can do is place the first sample in the first row of this matrix, second sample in the second row, and the last sample in the last row of the matrix. So because each input data is a vector of n-dimensional, and you have m samples of them, so overall in the end, this data matrix X will be an m by n matrix. Similarly, you can construct the observations of all samples here to be y1, ym here. So that in the end, y will be a vector, contains m values. It will be m-dimensional vectors of that. That's y. Similarly, you can put a theta, that's the vector we have here, same as before. And then in that case, you say because X is a matrix, and then if you look at what is the X time theta here. So that itself will be a vector because X is a matrix, m by n matrix, times an n-dimensional vector. So that will give you an m-dimensional vector, that is y hat. So y hat, you can imagine now, in this representation here, will be a m-dimensional vector with the first component represent the predicted values for first sample, and the second one will predict the values of the second sample, last one will predict values of the last sample. And you put all the predictions together, that will be a vector of prediction y hat. And then the MSE under this representation was simply the norms of y hat minus y. So y hat minus y is the residual. But in this context here, y hat minus y is going to be an m-dimensional vector. So I take normals, a square norm of that. So that will be something like MSE and divided by m. That give you the mean squared error. So that's when I have this coefficient in front of that to in order to calculate the average of the samples from individual ones here. So you can also write down this MSE in terms of this, write down the specific form of the norm here to be this vector product here, inner product between two vectors. So that is MSE and represented through this matrix representation. Okay. We'll come back to this point here because this is the kind of most compact representations of the, including entire training data sets, including the observations as well. So I don't need to write down the indexes, but if I use this matrix representation. So this is called matrix. We'll come back to this point here, but later on we'll show you there's a way to simplify our notations if we use this representation. All right, so now go back to the